Good afternoon, class. Let's get started. Okay, today is Friday, so I have to check your attendance. But before checking it, here's the midterm grade distribution. So our class is F68, right? So you can check the average grade and the median score. And yeah, the grades will be assigned separately for each class. So yeah, the Korean class students got better score, but no worries. And I think possibly the this class scored lower due to my bad English skills. So I'm sorry for that. Okay, and from last class we have some questions. So the first question was, is the concept of synchronous we learned today different from the property of a CPU, the synchronization? So the two things are totally different. So the CPU's clock synchronization means the CPU operations happen following the clock's signal, and the previous lectures, the terminology synchronous means the event occurs currently followed by the current executing instruction. So the two concepts are totally different. The second question was, are system cores defined in the kernel? And the answer is easy. Yeah, it's yes. System cores are defined and implemented in the kernel. So there was also requestment for the guideline to follow the previous lecture's live demonstration, but I think I don't have to offer some guideline because following the previous live demonstration is very easy. So you only need to open the terminal from the some Linux operating system. So you can install, if you are currently using Windows OS, then you can easily install Windows subsystem Linux, or you can install Linux via virtual machines. So just open a terminal and type the same command what I used during the last class. So then you can easily follow the live demonstration. And the last question was, why does echo trigger so many system calls? From the last class's live demonstration, we checked that the echo hello world triggered about 100 system calls, and it is because we have to load and close many libraries, and we also have to reserve some space on the memory. So that's why we need about 100 system cores to run the echo hello world. So to execute the program, we have to use some system core, and for open and close many libraries and related files, we have to use many system cores. And to reserve the memory space, we have to use the mmap to set up the memory regions. And also, even after loading and reserving the memory space, we have to use fstat to check information of the files and the standard alpha. That's why the echo triggers so many system cores. Okay, that's all for the survey question and answer. Now, let me check your attendance. 실바, 윤민성, 모, 티키나스, 루카스, 조윤솔, 이수민, 레오, 실파, 오렐리, 김민성, 표, 노연우, 윤아라, 이강민, 완, 한채영, 루슬란, 베네딕트, 안현식, 아므리나, 차승호, 조은채, 이동훈, 네이슨, 하미마, 정준희, 이재준, 김동현, 툰, 이민훈, 송민혁, 강희진, 손아현, 김예원, 박승빈, 네. 최지원, 남이, 찬, 김다희, 김민채, 강한결, 전영재, 이주호, 알반, 방채진, 박희현, 강민수, 슈디, 김현중. Did I miss anyone? Okay. Okay, let's start the lecture. So from today, we're gonna learn about operating system structure, and we will overview the concept of the Linux. So, like similar to the last class, today's materials will be also gonna be easy. Yeah, so no calculation and no code, so you can easily understand the contents. So from last class, we have learned about the view of operating system and some concepts. So operating system sits between the user program and hardware, and we have learned about system course, which offers some communication service between user and operating system services, right? And today we were gonna learn about the big picture of the operating system and their structures. And for today's course, you can refer the textbook chapters 2.8 and 2.20. So the today's class will cover various ways to structure the operating system. We're gonna learn about the monolithic structure, microkernels, and we will not cover the layered approach. And we will also cover the modules and hybrid systems. Firstly, the early operating system was built in monolithic structure. So the monolithic structure means the simplest structure for operating system. So actually it doesn't have any structure. It implements all the operating systems, all functionality into a single binary and into a single address space. So for example, in memory space, every functional, every implementations and codes are implemented in one single address space. So the original Unix operating system, the early operating system, it's a good example of the monolithic structure, and it has some limitations. I'm gonna explain it further. So traditional Unix system software, Unix operating system was consisted of two separate parts, the kernel and the systems programs. At here, system programs means shells, compilers, and some system libraries. So this traditional Unix system only included these two parts, kernel and the system programs. And yeah, and Unix used the monolithic structure. So let's say we have a memory and we have a memory space. So the monolithic means one huge block. In Korean, 한 덩어리로 된. So it doesn't have any separate parts. So all the kernels, kernel cores and some instructions will be located in the one single address. So there is no separate blocks for the monolithic structure. So the advantage of this monolithic structure is performance. So because all the code and implementations is located in a single address space, we don't have to find some other parts and so there is a very little overhead. At here, overhead means cost. So using system core interface is very efficient. You don't have to search other parts or vice versa. So communication within kernel is very fast. So the performance is the first advantage. However, as for the disadvantages, it is difficult to maintain and upgrade the code because every code is written for the single address space. There is a huge interdependencies between and among the code. So maintaining the security and reliability is hard to. It's the disadvantages of the monolithic system. So because every code is written in one single address space, they are very interdependent, and any component of operating system can ruin the entire system. So for example, Windows XP, the old operating system, has over 120,000 versions and 35,000 drivers. And among the 85% of Windows XP's crashes arise from the drivers. So to handle and implement these drivers, if every operating system's components are written in the single component, their interdependence will be very huge, and it's gonna be very difficult to manage all these drivers. Yeah. So the low modularity is the disadvantage of this monolithic structure. So to this end, to solve this problem, micro corner is suggested. So users, more and more users was try to use the Unix, and the size of Unix was expanded, and the kernel became large and difficult to manage. So in the mid 1980s, researchers from Carnegie Mellon University developed an operating system called March, which supports modularization. And and note that Apple's macOS kernel Darwin was based on this micro kernel approach. So this structure, this method, removes all non-essential components from the kernel and implement them as a usual level program. So let's say we have a kernel. We have kernel, and some components are not essential. Then this micro kernel approach will remove these components from the kernel, and they will implement such functionalities as a user program. So the kernel, the size of kernel will be smaller. That's the name microkernel means. So they generally provide minimal process and memory management and some communication facilities. So here's the architecture of a typical microkernel. So microkernel's main function is to provide communication between the some client program and various services. So here's a kernel, and let's say this previously in the monolithic structure, like file system and device driver will be located at here. But in this microkernel method, they remove these kinds of unnecessary components from the kernel, and they implement them on the user's side. And the microkernel's main function is providing this message passing. So let's say we have a one user program, and this user program wants to use the file system. It wishes to access a file. Then it must interact with the file system, right? However, to use the file system, this client program, cannot interact directly. So it have to use the message passing through the kernel. So all the messages will go through the kernel code. So this inter-process communication will support this message passing between these two user programs. That's that's the architecture of the typical microkernel. So to use the other user programs services, you have to go through the kernel. So here's the microkernel's pros and cons, advantages and disadvantages. The benefit of the microkernel is easier to extend the operating system. So because we separated the non-essential components from the kernel, so our new services can be added easily to the user space, and it will not require modification of the core kernel, the essential part. So easy to add services, and because of this modularity and low interdependency, the microkernel can be more reliable and secure. However, as for the disadvantages, the performance of microkernel can be diminished due to increased overhead of communication. So for this communication, we have to go to the kernel space and use the inter-process communication, even if we currently using the two user services, right? So there will be more overhead to between this communication. And so firstly, we using this application from in user mode. And for the message passing, we have to go to the kernel mode. And third, to use file system, we have to switch from the kernel mode to user mode again. So this kind of communication will generate frequent switching between user mode and kernel mode. Yeah, so it will also decrease the performance of the microkernel. Yeah, so from now on, we have learned about the microkernel and monolithic structure. And now I'll give you a example of the example operating system that which uses microkernel and monolithic structure. So Andrew Tenenbaum, who is the professor of health Finland University, invented this Minix, Unix-like operating system. At this time, the Unix was not free operating system. So if you want to use the Unix operating system, you have to pay for it. So, however, students are not rich, right? So we don't have much money. So this professor invented this for education purpose, and he used this Minix as an operating system lecture and practice materials. And he only developed the basic resource management part, based on microkernel, and Unix utilities, some tools can be used on the Unix. They are not available. And Linux Torvalds, you may have heard about his name, right? Yeah, Linux Torvalds. When he was a graduate student, he implemented his own kernel while studying Minix. So his Linux used the monolithic structure. So and he also supported the early Linux also supported the Unix utilities. So many graduate students shared the code and used his early Linux. So the Linux is a modern free operating system based on Unix standard. Torvalds developed this thing as a small but self-contained kernel. At here, self-contained kernel means it includes most core operating systems within the kernel itself. So it means that to use the early Linux, you don't have to install or add some many stuff. And nowadays, the current Linux's version is 7.0, and I checked recently. So you can check the email from Linux Torvalds at here. So what would you like to see most in Minix? So he felt some discomfort during using the Minix, and he tried to make the new operating system, new kernel. So I'm doing a free operating system for just a hobby and won't be big and professional like GNU. But it was not just a hobby. Yeah, nowadays everyone uses Linux these days. And at here, GNU means GNU is not Unix. So they are a free and open source community to develop a Unix-like operating system. And as I told you, Tenenbaum, Minix used the microkernel, so he liked microkernel, and Linux Torvalds, his Linux used monolithic structure. So there was a debate about monolithic versus microkernel. And if you go to this link, you can check the history of debate between Torvalds and Tenenbaum. So Tenenbaum attacks Linux as Linux is obsolete, and he argued that microkernels is the future and criticizes Linux's monolithic design as outdated. So who's the winner? Torvalds won in practice. So nowadays, many people are using the Linux. However, as for the theory, Tenenbaum was partly right, because modern operating systems such as Windows or macOS, they are currently using a microkernel approach. And if you go to this link, you can check the codes between them. And personally, this code was very interesting for me. Tenenbaum said, "Be thankful you're not my student. You do not get a high grade for such a design." So I think he really disliked the Linux's monolithic structure. However, nowadays many people are using the Linux. Okay, so from now until now, we have learned about the monolithic structure and the microkernel. However, modern operating system implement load-over kernel modules. As I told you before, monolithic structure has limitation. They doesn't have good modularity. So to cover that, modern operating system use this load-over kernel modules. They use object-oriented approach. So here, object-oriented approach means it divides some functionality into separate modules, and when some function is needed, then it will load the separated modules. So every core component is separate, and every module is loadable as needed within the kernel. So we will now cover the layered approach, so you don't have to know about this sentence. So the loadable kernel module approach is similar to microkernel, but the big differences between the microkernel and loadable kernel module is there is no messaging communication in this module approach. I'm gonna go through about this loadable kernel modules later. In modern operating system like Windows and macOS, they currently adopting hybrid approach. So they use the microkernel and monolithic approach at the same time. However, there is no modern operating system actually built on the pure model, because they try to learn the advantages from each other. For example, monolithic structure try to get some good advantage, very good feature from the microkernel, and microkernel also try to learn and get the good feature from the monolithic structure approach. So in this hybrid system, their core kernel is built in monolithic structure. So like scheduler, which requires high performance, they uses this monolithic kernel. And for the device driver, which doesn't have to act very efficiently, they use this microkernel approach. Yeah. However, Linux is still mainly using monolithic structure. We're gonna learn about it later. Okay, that's all for the operating system structure. Do you have any questions so far? a light. Then let's go through the Linux overview. So we're gonna learn about what is Linux and Linux kernel, what is Linux and Linux OS structure and components. So why do we have to learn about Linux? Because Linux is running on around 80% of servers and embedded systems. So, and it also offers many advantages over other operating systems. So, it is free. So many servers and embedded systems are adopting Linux because Linux is free, and it supports good documents, and they have a large community, and yeah, so that's why Linux is good. And then why do you have to learn about the Linux kernel? Because kernel is a central part of operating system, and learning Linux kernel means understanding the detailed operation of kernel, and you have the ability to improve the several parts of the kernel. So to become an advanced programmer who can perform the code optimization and who has good debugging skills, you have to know and understand the Linux kernel. So it is and also it is very essential if you wanted to become an embedded system developer or engineer who deals with the low-level hardware interfaces. So to develop device drivers, you have to understand and study the Linux kernel. Okay, that's why do we have to learn about Linux and Linux kernels. And now I will talk about the Linux system. So Linux uses many tools developed from other developers. So it uses part of Berkeley's BSD operating system and MIT's X Windows system, and many other free software from the GNU project. So to understand and use the Linux system, you should be familiar with BSD or other GNU project programs. So the Linux system is maintained by developers from Linux community, and the main system libraries were started by the GNU project. And at here, if you use the Linux or Ubuntu with GUI, I think some of you have encountered the term X11 or something. This X11 is the part of MIT's X Windows program, GUI for Linux. Anyway, and we're gonna talk about BSD operating system later. And we already talked about the GNU project previously. So, okay, so, and also I think most of you have encountered this Linux or Unix style file system, right? Hyphen home or something. It is the part of the file system hierarchy standard, which is documented by Linux community. So they try to ensure compatibility across various system components by using this file system hierarchy. To maintain it, they specify overall layout of the Linux file system and blah blah blah. Okay, and as I told you before, Linux uses the BSD, Berkeley Software Distribution. And in early 1984, AT&T, the America's SKT, America's, how can I say, 통신사, communication, 통신사가 영어로 뭘까요? communication company, telecompany, telecommunication. Thank you. America's telecommunication company. The AT&T was divided by anti-monopoly law, 한국어로 단독점법, and after this divided, many Unix developers moved to UC Berkeley. So before this dividation, the AT&T developed Unix, and you have to pay to use this Unix, and some of Unix developers moved to UC Berkeley and developed a Unix-like operating system, which is BST, for free. So people who have tasted free Unix are desperate in need of alternative. So they developed GNU and Linux. And yeah, because it was at the time it was very popular because it can replace Unix for free, and the developers of BST was faced a legal dispute with AT&T due to the Unix technology leakage. Yeah, but thanks to them, we can now use the Linux. So from now on, until now, we have learned how the Linux system was built and what kind of things were used to build the Linux system. Now let's talk about the design principles of Linux. So Linux is multi-user, multitasking system with a full set of Unix compatible tools. So to support this Unix compatibility, they try to copy or mimic many features and standards of Unix operating system. So even its file system adheres to traditional Unix semantics, Unix grammars, and it fully implemented the standard Unix networking models. So as you can see, the Linux really try to support the Unix compatible tools. So from the last class, we have studied about the APIs and system calls, right? So the full name of the POSIX is Portable Operating System Interface for Unix. And to support the Unix compatible tools, Linux is designed to be compliant with POSIX. That's why we can use the POSIX APIs from the Linux. So yeah, POSIX is some APIs for Unix, and they standards for Unix-based operating systems, and it is specified IEEE Computer Society. So they set the standard rules and guide to use the POSIX, and so it includes the command line shell and file systems, and they can be used on the Unix-based operating systems such as Linux, Android, or macOS. And now let's talk about the Linux's operating system structure. As I told you before, Linux really tried to be compatible with Unix, so it mimicked the Unix's structure. So Unix used monolithic structure, so Linux is also used the monolithic structure rather than the microkernel. So they places all of core functionality of the kernel into a single binary and a single address space. So the building the Linux kernel will result the image file in a single file. However, Linux's monolithic structure has some limitation, low modulability, right? So to solve the problem, Linux operating system support the modular design, which allows the kernel to be modified during the runtime. So a kernel module is a piece of software which aims to extend Linux kernel's some new features. for example, while running the computer, we plugged in a new GPU. Then to use and support the new features to use the GPU, we need some new softwares, right? To support them, we can use the loadable kernel modules. So during the runtime, if we plug the GPU, we can load the new kernel modules to support the newly plugged GPU. So Linux has this modular design and also support the loadable kernel modules. So during the runtime, you can add new device and new USB or new disk drive, because these loadable kernel modules it supports the device drivers and file systems. So yeah, so this LKM loadable kernel modules can be inserted or removed during the runtime. Yeah, it's like USB device can be plugged into and plugged out during a runtime machine. So, and lastly, we were gonna go through the Linux's main bodies of code: kernel, system libraries, and system utilities. So at here, this system management programs and some user utility programs and some compilers, they belong to the system utilities, and we're gonna go through about the detailed things about these three body functions. Okay. So until now we have talked about kernel many times, right? So kernel is responsible for maintaining all the important abstraction of the operating system, and every kernel code executes in the kernel mode, the privileged mode. So the kernel have a full access to all the physical resources, all the hardware of the computer. Yeah, that is the kernel. And in Linux, every kernel things and every kernel code and data are kept in the same single address space. And as for the system libraries, it defines a standard set of functions through which application interact with the kernel. And so the system libraries implement much of the operating system functionalities that does not need the full privilege of kernel code. So much of the system libraries can be run on the user mode, so they do not require the kernel privilege. So the most famous system library in the Linux is the libc or glibc. To use the C library in Linux, you have to use libc or glibc. I think some of you have already used this glibc if you use the C compiler or C library in Ubuntu. Yeah, so that is the system libraries. And lastly, we also have the system utilities. It is very similar with the system services like file management things. So they are the programs that perform individual specialized management tasks. So some system utilities are invoked just once to initialize and configure some aspect of the system. At here, I want to introduce a term, daemon. So daemon is one of the system utility. So daemon is a background process that runs in the background. So they do not interact with user. So if you are not carefully look inside of the kernel, you cannot recognize its existence. So they are managed through init scripts such as etc init .d. And the good examples of daemons are web servers or database servers or logging services. So without users' interaction, in the background, the computer run the web servers and database servers and log the system's traces without users' interaction. So these kind of things are the part of the daemon. They are run as a daemon, and this daemon is included in this system utilities. Okay, and this is the today's last part, the kernel modules. So as I told you before, Linux support the load-over kernel modules, right? So the kernel module means sections of kernel code that can be compiled, loaded, and unloaded independent of the rest of the kernel. So from the monolithic structure, the core part of kernel is located and in a single address space, right? However, the kernel modules can be written independent of this core kernel, the monolithic kernel. So this kernel module typically implement device drivers, file systems, or some networking protocols. And due to these kernel modules, the third parties like NVIDIA, which manufactures the GPU, they can write and distribute their own terms on device drivers that then not distribute under the GPL. So to understand this meaning, you have to understand the meaning of the GPL. So GPL is a free software license that allows users to run and modify the software and their code. However, if you use and modify this GPL license things, you also have to release your modified source code under the GPL license. So the main part of the Linux kernel is written in GPL license, under the GPL license. So if you want to use and modify the Linux's core kernel, you have to distribute your code for free and open source under the GPL license. However, because Linux supports these kernel modules, they are independent. They can be loaded and compiled and coded independent of the Linux's core kernel, which is written under the GPL license. You can the third parties can write the device drivers regardless of the GPL license. So if you write the kernel modules, you don't have to use the GPL license. So if you are the third-party manufacturer, you don't want to share your device driver code with others, right? So because due to this kernel module, you don't have to use the GPL license. So yeah, so they treat it as separate code, so they do not need to be released under the GPL license. Okay, any questions so far? Okay. So this kernel modules allow Linux system to be standard and minimal kernel without any extra device drivers built in. And to support these kernel modules, Linux have to support module management system, module loader and unloader, driver registration, and complete resolution mechanisms. Yeah, let's see. So to support the kernel module, the operating system should support module management and also the module loader and unloader. So this module management supports loading modules into memory and letting the kernel took the left of the corner, letting them to at here means the modules took to the left of the corner. So module loading is performed in 2 stages. So firstly, the module loader asks the kernel, like a module management system, to reserve the continuous area of kernel memory for the module. So let's say we have a kernel memory space. Then firstly, the module loader asks the kernel to reserve a continuous area of address to load the module. And after loading, if kernel says yes, then the module loader will pass through the module and along with any symbol tables that new module wants to export to the kernel. So if the module is loaded to this kernel space, other user programs or other modules can want to use this module, right? So to let them to know the this module is supported, they will export some symbol table to the rest of kernel. Yeah, that's what module loading process is done in 2 stages. And we also have a module requester. So it manages loading requested, but currently unloaded or some things. So it regularly queries the kernel to see whether the loaded module is still in use. And if the module, it tracks the module uses, and if the module is not used, then it will unload it when it is no longer actively needed. So it can, by unloading this, we can save the memory space from the kernel. Yeah, that is how the kernel modules support the module management and module loader and unloader. And we have to also support the module registration. So module registration allows modules to tell the rest of kernel that a new driver, new functionality has become available. So the kernel maintains dynamic tables of all known drivers and provides some routines and functionality to the other codes from so they can use the new functionalities. So this table includes the following items: the device drivers, file systems, network protocols, and binary formats. So, for example, as for the device driver, if a user added a new mouse, then the information of this device driver will be added into this table. So user or the other kernel or other program can refer this table and it can use the new functionality. And at here, driver or device driver means a software component that lets the operating system or device communicate with each other. And it from the last class, we have learned about the device controller, right? I think it is some confusing part. So device driver is a software, and just think as the device controller as a hardware. So we have I have told you that device controller includes the local buffer, right? It is a part, so it's a sort of a hardware. Okay, the last part. It is a conflict resolution. It is a mechanism that allows different device drivers to reserve hardware resources and to protect those resources from accidental uses by another driver. So we have, let's say we have one hardware and 2 drivers, and these 2 drivers wants to use the same hardware at the same time. So this situation will occur a conflict, right? So to prevent this situation, this conflict resolution is needed. So to So this conflict resolution module aims to prevent modules from crashing over access to the same or many hardware resources. So we have to prevent this situation, right? So, and also it prevents auto probes from interfering with existing device drivers. To understand this sentence, we have to understand what is the probe. So probe is a code or some function that runs when a specific event or code location is reached. So, and this auto probes automatically insert such probes into kernel code for debugging or and monitoring. So, so auto probes can so auto probe can insert some probes to like a device driver probes when automatically detect the device configuration. However, this newly added this probe or device driver can interfere existing device drivers. Yeah, so to prevent this situation, so we have to this conflict resolution will prevent the auto probes. Yeah, so and the resolve is to resolve the conflict with multiple drivers or try to access the same hardware. The kernel will maintain the list of allocated hardware resources, and the dedicated driver will reserve the resource with the kernel database first. And reservation requests will be rejected if the resource is not available. Yeah, so in this way, you can perform the conflict resolution. Okay. So the previous Korean class ended at here. So yeah, that's all for today. So any questions so far? Was it clear? Okay, so let's stop it here, and before ending our class, let's take a survey. 스승의 날 축하 고마워요. Thank you for celebrating Teacher's Day. Okay, then that's all for today. Enjoy your weekend and see you next time.